Yes, hey, welcome back. Yeah, I was thinking of what to do for today, and I thought I'll do something special, and that special did not work out that good. So I defaulted to doing N queens attacking. And yeah, if you stay till the end, I'll show you what I tried to do something special and how it felt spectacularly also. But now, directly let's get on with the N queens attacking. And this is like the most popular recursion slash backtracking problem. And yeah, and the question is again pretty straightforward. If you know how a queen, if you know ABCD of chess and you know how a queen moves, then you will understand the question easily. You will be given a board, size of the board, and you have to tell like if you can place queens in the board such that queens should not attack each other. And yeah, if you don't know chess, then I'll tell you. Queen can move in all the diagonals and the entire row and the column in which it is placed. Yeah, so it might seem daunting at first, but it's not that daunting. And I think this can be extended to placing bishops and rooks also, just by modifying the what you tell the movement of the queen. We can place it try for rooks and bishops also, and I did not test that out. So after doing this, let's just check that out also. And yeah, let's define the class. Yeah, it's called as n queens because we'll be given n queens to place on the board, and so that they should not attack each other. Yeah, again we'll have a lot of initialization to do. And yeah, again, we'll use the cute emojis to represent the board, and we'll go along with that. And yeah, so what we'll do, and first let's like we'll not declare everything at the beginning itself. We'll declare as we go. So first, let's have an object of our n queens, and yeah, in the n queens we'll have what do you. So yeah, I think what will be a good name? Yeah, we can tell it n queens dot solve board, and we'll get the number of queens. And yeah, initially let's have 5 queens. So yes, and so we'll declare solve board. We have to again put self over here because it is used inside a class. So to refer to the object of the class, you have to use self, and you'll get the uh, number of queens. And yeah, the assumption is that the board size will be equal to the number of given queens. So if you are given 6 queens, then the size of the board will be 6. So yes, self dot queen will set it to number of not non-local number of queens, and self dot board size we will set it to number of queens. And yeah, now let's declare this variable. Unit actually 0. Again, you can directly pass it through the constructor, but yeah, for directly putting n queens comma 5 won't look that good. So I'm using a separate function to do that. Board size is 0. And yeah, the same. It's pretty obvious that since we have a board size, we will have to generate the board. So self dot board will actually be equal to null array for now. And yeah, first now let's generate the board itself. Again, it will not take any arguments because we have the argument in the form of constructor itself. In the constructor, we have the arguments, and we can directly use that. So what we'll do is for I for the row, we can't use the length of board size over here, and that is because yeah, board size is actually an integer, and if you do length of integer, that makes no sense. You'll have a temp array over here, and for call in range dot board size temp dot append. Yeah, what we'll do is that initially we'll set all the squares to be 0, meaning that yeah, 0 means that square can be occupied or attacked, and 1 means that the square has already been attacked, like it is under attack and you can't place anything over there. And the thing is, we don't actually need the value of row or column over here, so let me just replace it with anonymous value. Like when you use underscore, it will tell that yeah, that is not actually being used. And yeah, after this, what we'll do is board size dot append the temp. Yeah, by now what will happen is that your board will be generated. So generate board. Now let yeah, what I always say is that print and print. Whenever you make something, just print to check it out if it is working properly. So let's just print out the board size. So let's just print out the board to check if it is working. Yeah, it's actually not board size. I don't know why I wrote board size. It's board over here. And as you see, you're getting five. Yeah, there are five elements, like five rows and five columns, and each column has five rows. Yeah, and that's what was expected. So now what we'll do is we'll directly do the backtracking part. So to do the backtracking, you can't directly modify the value of queen. So we'll pass the queen over here. And now let's define the backtracking part. Again, you'll have a self over here, and you'll actually get the number of queens also. So you'll call it queens. And yeah, so I again what you'll do is you will first generate the board, and for each position in the board, you'll put the queen there, and then continue recursion from there or backtracking from there. Again, you will place another queen. Again, continue the recursion. It goes on like that, like that. So what will be the base case? So if queens become equal to zero, that means that you have placed all your queens and your work is done. So you can directly return the board. Just good board. Or else what you have to do? Iterate through all the given rows and columns. After placing one queen, iterate through the entire board and check if you can place another queen. So for row in range length of self dot board, or you can do board size also. But I prefer to write length of the array itself rather than going with board size. Again, don't forget to add self over there. So what you have to do? If the given position is valid, so when will the position be valid? It will be valid when there is no attacking over there. And when how have we like defined the attacking? We have defined that if the position is one, that means that the position is being attacked. So if the position is valid, so if it is valid, if it is a valid position, then only we can proceed. Yeah, let me define the valid position over here. And yeah, what is it? You have to put self over here because you are calling it inside the class. Only if it is a valid position, let myself over here. You will take the row and the call. And if the given position is a valid position, then what you will do? You will actually place a queen there. So self dot board at the position row at the position call. What you do? You'll place a queen there, and you will tell after placing the queen. What you will do is you will start the backtracking. So result it's not result. Its result is actually self dot backtracking. Since you have already placed a queen, what you have to do? Decrement the number of queens by one. Queens point, yeah. This is basically it. And after all the recursion is done, what will happen is first it will place one queen, and then it will go for the next iteration. It will place another queen. It will go for the next iteration, and so on. It will continue. And so, what does that mean? After this result is calculated, you will actually have the entire array itself. It's not like you have to go and recheck it again because each time it will be calculated and the board will be returned as soon as you get a valid solution. So, if the result exists, that means you can actually return. I hope you got it. Why we are doing like that? We can directly return the self dot board. And if the actual position is not valid, what does that mean? That means that you could not actually you could place a queen there, but it will not give you a valid solution. So self dot board at the position row at the position call. Just tell that it can be attacked further down the line, like if some other at that position might be valid for some other position. Yeah, and believe it or not, this is the entire backtracking part. And now let's do the is valid position part. You will have the row and the call. So yes. So how does the queen move again? The queen will move in the diagonals, in the rows, and in the columns. So let's get the rows out of the side part. So for let's call it rows and columns. Yeah. So if board at the position I, which is row, at the position J, which is let's call it IJ because rows and calls will be confusing. No, let's call it IJ itself. And yeah, for row, no, let's call it row and column only. But what you do? We will not call this as row. We'll call it as I. So how will you calculate row? For each constant I, you will change the row. So row is actually set, and for each I, you will actually check for that position. I hope you got it. Should I think it's better if I explain again. So what you'll do for each row, you'll keep the value of row constant and you'll just increment that so that you'll go to next row. And yeah, you just check if it becomes equal to one. That means that you can't place anything over there, and that is not a valid position. So return false. Yeah, again do the same for column also. Yeah, if self dot board at position, now it will become I and call. Yeah, this means that you're keeping I constant, you're keeping the column constant and you're just incrementing the I. In other words, you're checking for each. Now, I told it to work. In this condition, you're checking for each column. No, I told properly. Why am I getting at this? Yeah. In this condition, you're checking for the each row. Like in the given current row, if the queen can be placed. And in this one, what you're doing is that you're checking for the column. So in other words, from top to bottom, you're checking if the board pin can be placed there. So and yeah, it is obviously you see that if it becomes one, that means that that position is being that position is actually occupied by a queen, so you can't place anything over there, so you'll return false. So now what you have to do? Now go for the diagonal, and yeah, technically you will have four diagonals. So from any given point, you can actually draw four diagonals. One which goes from to the top right, other which goes to the top left, other which goes to the bottom right, and other which goes to the bottom left. So now let's get that out of the way. Now, so how we can do that? Just have L and R to be equal to row and the column. And yeah, while L is greater than 0 and R is greater than 0, what you do? Do just do L minus is equal to 1 and R minus is equal to 1. That means you're going to the top left. So if again self dot board at the position left, at the position right, if it becomes equal to 1, that means that you cannot actually place a queen in the given position. In yeah, again I will tell it is not that you cannot place the queen in position L comma, but it is that you cannot place the queen in the position row comma column. Don't get confused over there. Yeah, and so if it becomes equal to true, then return false. If there is a one over there, then return false. And again, yeah, we have to do this for the three diagonals. Let's give proper spacing. And yes, while L is greater than 0, now let's do for while L is less than length of self dot board, self dot board, not comma. And R is also less than length of, yeah, what you do? You have to increment R by 1 and increment the left by 1. In other words, you're going to the bottom right. So over here, you went to the top left, and over here, you're going to the bottom right. Yeah, just visualize it once, or else you just take a pen and paper and write it out once. You'll understand why this works. And yeah, again, do the same thing. Now, what you have to do? Now, you have to check for the positive and negative diagonals. So let's do that properly. You have to check for the other two diagonals. Like now, what happened is from the top left to bottom right diagonals we check. Now you have to check for the diagonal from top right to bottom left. So yeah, while left is less than 0 and right is greater than length of self dot board. Yeah, you have to do put greater than or equal to, or else you'll get index out of bound error. So while left is less than 0, you will decrement left, but while R is greater than the length of the self dot board, yeah, no, no. While left is greater than this 0, will decrement left, and while R is less than the self dot board, will increment the right. So what is that? Just again, I am telling you directly. Don't search for the answer, but visualize it once. So you are decrementing left, and you are incrementing right. That means you are going to the top right. And now we'll do for the, yeah, even I was visualizing once, thinking if I told wrong. And now we'll do the same for the last remaining diagonal. Again, we'll just remove 0, 0 there because those are the wrong conditions. So what we did is we checked for L is less than 0 and R is greater than int of self dot board. So we'll do the opposite over here. Well, board and R is less than 0. Hey, wait a minute. This is actually not the correct condition. You can actually reach 0, but you cannot actually reach the length of self dot board. You will give index. You will get index out of bound. Yeah, this mistakes happen to everyone. Yeah, and while L is greater than less than self dot board, you increment left by one, and while R is less than 0, I mean R is greater than 0, you decrement right. And after all these conditions, if there is no return value, that means that you can actually place a queen in the given again. I'll tell row and column. You can actually place the queen in the given row and column, not in L and R. So that means that you can directly return true. And by this time, I think our board has to be filled also. So for the self dot board, we'll just print B and check out if we have made any mistakes. And yeah, it looks like we have not. I think there's no need to return anything. Yes, yeah, there's no need to actually return the board also because we are actually directly modifying the board value which we have taken in the constructor. And as you see that, okay, I think we have to return the board over here. Yes, we have to return the board. Yes, now you see that it's actually modifying everything properly. And yeah, what you see is that you can place one, and that no one is there on row and column, and then you take this one. Again, you see that there's no one in row, column, or the any given diagonal. Yeah, take this one. Again, you can see that there is no one on given row, column, and diagonal. And it's the same continues for other things. So we have successfully implemented the backtracking cut. Now let's beautify it. So what we can do is, yeah. Now what we'll do is we will again do the age-old emoji. So again, oh, okay. Now I think I have written down the values of the black. I think we have the value of black and white square in nice.py. Yeah, black square, white square we have over here. Yeah, let's do the same thing. Yes, we actually have the value of black and white square. Now what we just want is the value of the queen, and I think I have written the value of queen also somewhere. Yeah, and the value of queen is actually, yeah. Don't directly write queen because we already have a queen variable declared, so we'll call it queen emoji. It's actually slash u2645 my bad. Yes. And believe it or not, while I was writing the code, I was going like really fast. And over here, rather than doing L minus is equal to 1, I did L minus 1. And I was confused so hard that where I have made the mistake because I have implemented everything extremely properly. But whenever I tried to do for, and believe it or not, for every value it was passing, but for when we took L is the number of fields is equal to 6, I was getting the wrong value. Like fields could attack each other, and I was about to bang my head to the wall. And then I closely went to code and saw that I had written is equal to minus 1 and don't do mistakes like that. So it's L minus is equal to 1. And yeah, now what you have to do? Let's remove this part for now. Yeah, now, yeah, now directly let's make our board. So again, you take nothing over here. So what you have to do? Yeah, let's declare a good board over here or ready board. It's not board, it's board, yeah. Be careful to name everything properly. Don't name anything A, B, C, D and all. Then you won't understand what you're doing when you go further down the line. So now what you have to do for, again, the same thing which we did for nights. If you remember what we did, where is that? Where is that? Yes, the same thing we have to do. If the because I hope you understood why we have to do this. The top every black square will be placed in even positions, and every white square will be placed on odd positions, like the sum of row and column. What you have to do? Take the sum of row and column. So if you can do sum of row comma col also, but yeah, let's make it more understandable. Let's not use sum and all. So we'll not use any inbuilt function. So row plus col, And yeah, don't forget to add the brackets over here, or else you'll get wrong values and you won't understand why. If it becomes equal to 0, that means you'll have to have a temp over here. If it is equal to 0, that means temp dot append the black square, else the white square. And yeah, again, think carefully of this. By now, what has happened is that you actually have your board also. So after checking this, if you try to add your queens, yeah, what will happen is that it is not proper. So what you have to do is, uh, now we can add it. We can add our, yeah, we can directly add our queen over here. And if the self dot board at the position row at the position call, if it is actually equal to 1, that means that the queen can actually be placed there. So yeah, the thing with doing like this is that since you have not declared the size of the temp, you can directly access that index. So what you have to do, yeah, like you technically you can access it using row, or you can access it using call, but rather than going through that hurdle, what we'll do is we'll do it like this. And yeah, but if the actual position is 1, then directly to temp you'll append the queen emoji. Else if the yeah, row module to 0, we'll append the black square or we'll append the white square. And yeah, now the only thing left is to print the board. Again, we'll take self over here. And yeah, there is no need to actually import time and all because we directly have the solution. So what you do for is for, so just print the value of board, good looking. Yeah, it is ready board, not just board. But yeah, you can actually use board over here because board and ready board both have the same size. At the position row, at the position column, you print. After printing the column, put the ending delimiter as a space. After printing each row, just print a new line. Yeah, by this after doing the backtracking, generate the board. After generating the board, print print generated board. Okay. Yeah, I hope you caught why it was not printing. Even I was like really shocked once. That is because after appending to the temp value, we are not actually modifying our good looking board or ready board. So it's just printing nothing over here because the length of actual ready board is 0. So it was not printing anything. So yes. Okay. Temp. Are you reaching this point? Okay, what is the issue? Let me just check it out. We are actually reaching this point. We are taking the temp. Yeah, I hope you got it. Why? Again, I was like really shocked thinking on why the what the error can be. That is mainly because, yeah, after doing this, you're generating the board, but you're not actually assigning the board itself, I think. Where is that? Yeah, I'm calling generate board twice, and I think I have called both the methods generate board. That is the main issue. Yeah, both are called generate board. Generate, let's call it generate ready board. Yeah, don't make mistake like that. It happens. Yeah, look at that. Look at that. Again, it looks really good. It seems that the queen is actually occupying one lesser space, so we'll just add a space after putting the queen. And yeah, now it looks proper. Let me just increase the size. One more and one more. Yeah, that looks good. And as you see that no queens can attack each other. And let me just reduce the size over here and let's try for six queens now. Okay, it looks like there is some small error again. The first two queens are not being placed properly. Is it working for seven? So, yeah, for seven selling, but it's working for five, right? It's working perfectly for five. That means that there is some error in this part. Yeah, again, it is actually greater than or equal to because zero can actually be reached. And yeah, now it's proper. See, don't make mistakes like that. I don't know why I wrote greater than zero. Again, I was about to bang my head to the wall thinking where the mistake has been, where the mistake has happened. And yeah, for six also it's working properly now. And now let's look for six. Yeah, again, there is some greater than zero over here. The mistake is from going from the top right to bottom left. So it is actually over here, I think. While L is greater than zero. Yeah, let's just check out each and every method once. So yeah, this method is working perfectly as intended. And then we have while hmm, yeah, I think I have missed out some method over here. Yeah, it's not this, it is this. L can never actually be less than zero. Ignore that also. And let's just check out each and every method. I think it's better to rewrite it because I think I made some major mistake over there while writing typing fast. So yes, so what you have to do for yeah, I think it's better we call this as I and J because that will actually be much more beneficial and we'll call this as row because we are iterating to each row. We'll call this as call because we're iterating to each column. And for board at the position I at the position row, if it becomes equal to one, that means you cannot actually reach that part at the position column at the position J. If it becomes equal to one, that means that yeah, I think the error was over here. or might it not be. But let's just continue to over here. Then false, that means that you can't actually place it over there. So you have L comma R is equal to I comma J, while L is greater than or equal to 0 and R is greater than or equal to 0. That means that we are going to the top left. So we'll do L minus is equal to 1, R minus is equal to 1, and we'll check if both at the position left, at the position right, is self dot board, it becomes equal to 1. That means that queen is actually present there, so you can't place the current queen at the given row and column. So yeah, and you're doing elements equal to 1, R minus is equal to 1. So next what we'll do, yeah, again we'll reset the value of L and R. So L comma R is equal to I comma J. Yeah, that's why I tell don't do control C, control V from top methods. There might exist some, you might forget to make some modifications. So while L is less than length of self dot bold. So R plus is equal to 1 and L plus is equal to 1. Yeah, this means you are going bottom right. So again, self board at the position left, at the position right. If it becomes equal to 1, that means that a queen is actually present in that position. So you can't place the current queen in the given current row and column. So and then we have to do for while L is greater than equal to 0 and R is less than length of self dot board. Again, you have to do the same thing. I'll just copy this part. And then what you have to do, since L is decremented, you do L minus equal to 1 and R plus is equal to 1. And the last method left, which is R is greater than equal to 0. Yeah, again, we can do this. And L minus is equal to 1, L plus is equal to 1, R minus is equal to 1. The line, error is at line 45. Yeah, that is because I forgot to reassign L and R over here. Again, I did not reassign L and R over here. And now you see, yeah, there was some logical error while going through the diagonals. And now you see that the board is actually proper. Yeah, you don't have the attacking queens. I think the error was in this method itself. But yeah, just to be on the safer side, I rewrote the entire thing once again. Then now let's do zoom, zoom, zoom. I hope this is the last time I have to do zoom. Yeah, and as you see that you have the queen. This has nothing in row, column, or diagonal. Again, nothing in row, nothing in column, and nothing which can hit it in the diagonal. Nothing in the diagonals, nothing in row, column, and yeah. As you see, it's perfect. It is working like really well as expected. And yeah, you can test it out for any given value. And if the given value is less, then nothing will be printed. You will not have any queens. Yeah, and for the three, you can't place any queens, but for four, you can place four queens, and for five also you can place queens. Yeah. Yeah, but at first what I thought was that we'll write every possible board, but then yeah, I just thought that the for each increment in the value of queens, the number of board increases much more, not exponentially, but much more than that, and it will just become so to like even if I write the code for that, you'll not have enough space to see all the possible boards also. So yeah, I see. This is actually a really. Just remember one thing: backtracking actually has the worst time complexity. You actually have to check for every possible combination. That's why even for such small value of 10, it takes such a large time. So whenever possible, try to avoid recursion. But this is the problem. Yeah, the NQN's problem is actually called a NP hard problem, which means that there is no possible way to reduce its time complexity from being exponential to linear or any other way. It will always be exponential. That's why it's called an NP hard problem. And if I make it 100, it will take, I don't know, with my that puny processor, it will take very long time to generate it. Yeah, and as promised, now let's what we'll do is that we'll make it work for rooks. And yeah, to make it work for rooks is very simple. Just remove this part. Yeah, and if you remove this part, it should actually work for rooks. And now, yeah, let's have the rook Unicode. It is not actually in the value of for Python. Mm, I think we can directly copy the value like this. Let's just check it out. Yeah, we can do that. So we'll call the queen emoji as, and we'll add a space like this. And yeah, as you see, it is actually just printing it in diagonals. And now you see that no rook can attack each other. And if you want it so that no rooks can attack each other, I think you have to place them in. Yeah, there are many other ways, but placing them in diagonals is the easiest. And yeah, if you change for any other value also, I think it will always go in diagonal only. Yeah. See, now you see that it is pretty obvious that no rook can hit each other. Yeah, let's do the same for bishop also. Let's have the bishop Unicode. So for bishop again, what you have to do is there is no need for major modification. Just uncomment this part and comment the above part. And yeah, again, it's as you see, it's pretty obvious that no rook, no bishop can attack each other. And yeah, placing bishops in direct, what you tell, straight line will actually tell that okay, you should not. You can tell that yeah, it's pretty obvious. I think if you know chess, you can see that the bishops cannot attack each other. And yeah, let's do the same for knight also. Why not? We actually have the directions over here. Since this is for queens, I will just just comment this entire part out. And yeah, and yeah, you can actually move in the given direction. So what you have to do is for dx comma dy in directions. First, again over here, what you have to do is you have to check if the given value is actually in bounds. So how you'll do that? You're actually getting the position you want to place. Yeah, I think for knights it will again be a bit hard to do because you have to check for many other things. So I'll just hold off to the knight for now, and I'll just release a separate video because I have not gone through doing this for knights. And yeah, just think about what you can do. You actually have the position of I and J. This is where you have to place your current this one. Yeah, I think we can do it. It's not that hard. I don't know why I'm getting scared. Just to calculate the value of I and dx and dy. Dx comma dy is actually I plus x and y plus j. And yeah, now what the extra check you have to add is that I don't know why I comment this out. The only extra check you have to add is that you have to check if the given dx and dy is actually inbound. So if dx becomes again yeah zero is less than 0 is less than or equal to dx is less than length of self dot board and 0 is less than or equal to dy is less than length of self dot board and board self dot board at the position dx at the position dy. Yeah, again, I think for knights also you can directly place them in a straight row. That means they'll not, never attack each other. That's why it's called the queen problem because placing the queens is actually the hardest. If it becomes equal to 1, that means you can't place the knight there. So, yeah, else you can directly return false. That means that. You are actually out of bounds and you can't place any knight over here. And, yeah, if silver board at the position df dy is equal to 1, that means you can't place. Oh, what is happening? I think we have to not do this. Nah, I don't know why it's not working. I'll just I'll do one thing. I'll just go over how to do n attacking knights also. Again, but for knights, if you place it on the same row, it should not actually attack each other. X plus and y plus j. And yeah, if this is equal to 1, that means that you cannot actually place your knight over there. Yeah, and yeah, board and silver board. Dx and dy only are checking. To 1, you can do it. Else, yeah, this will work actually. I don't know why. So placing the first knight over here. Yeah, let's just print out the. Yeah, it's actually checking for all the other positions and it's telling, yeah, you can place over 1 1 1 over there. But while returning, I don't know why it's not actually modifying the value. So yeah, now yeah, this was since this was mainly on n queens. So let's not think about n knights for now. I'll just go through it once and I'll release a video going on how we can solve for n knights also because it will be some minor modifications and I'm making some minor mistake again. Yeah, and I think yeah, that's all for it. And yeah, now I told right in the beginning I was about to do something different for that side. I'll just go over that one. So what I thought was that since I have coded for merge sort and I have coded for quick sort, I thought that what we'll do is that we'll actually combine merge and quick sort where it's hybrid over there. Yeah, I just combined merge and quick sort, and I thought yeah, if it functions better than merge and quick sort, then I can directly make a good video on that. And yeah, I did the combination and all. So what I'm doing is that actually for each iteration, if you see over here, first I'm actually calling quick sort, and in quick sort, what I do is that for each iteration, after breaking it for the first time, I'll apply merge sort on that, and after applying merge sort on that, and after applying merging and breaking and merging it for the first time, again I'll apply quick sort. Yeah, it's like for first iteration it's applying quick sort, for second iteration it's applying merge sort, for third iteration it's applying quick sort, and so on, so on. Yeah, and then what I did is that I just made a random number.py text, and in that I just generated random numbers from the range of some very big number, and yeah, and when you do that, it will take some time. But yeah, we generate the random numbers over here. Yeah, let me just remove everything over here, and let me just go to random number.py and generate again. Yeah, this is that this will get populated, and then what I did is that I made a function called number container preprocessor, which will actually just take all the values we have generated since it is in the form of text and we need it in the form of an array. What I'm doing for number container dot preprocessor is that I'm actually just putting it in an array, and in quick sort merge sort. Where is merge sort? Yes, quick sort and merge sort. I'm just calling that array. And I thought, yeah, let's just check it over. And I just, if I could do it as run code, it will run the actual code. And you see that for merge sort in on such a big array, it will take, I think, about 8 to 12 seconds. Yeah, it took 9 seconds. And on the same array, if you do quick sort, you see that it will take. Yeah, quick sort actually depends upon how close the array is to being sorted. And the more it's not sorted, it will take more time. And yeah, it took 8 seconds. And I was like, hoping with my fingers crossed that where is my hybrid sort. Yeah. I was hoping with my fingers crossed that this will take less time than that. And when I did the run code, I was actually like pretty disappointed to see that it actually performed bad than the about two methods, like the quick and merge solve. Yeah, and as you see, it performs like really bad. 10.23 seconds is no joke. It's actually like exceptionally bad. And I thought, yeah, when I'm doing that, let me just check out since the Python itself is a team sort. I thought let's check it out, check out how much time it takes for team sort also. And when I did this, I was actually like really shocked and disappointed because it ran in 1.98 seconds. It's running like 100% more efficient, not 100. It is running 10 times more efficient than mine. And yeah, that made me really sad also. And then yeah, then I panicked that okay, what I'll do for today. And then I thought, let's since I'm going in the form of chess, let me finish all the chess problems, which is knights attacking and then queens attacking. Yeah, I think that's all. That's all for today. Yeah, over here I had made some small minor mistakes. That's why it took much more time. And then I showed you how to do for rooks and bishops. And yeah, and in some other coming video, I'll do for knights also because I don't know why the knights were not working. There might be some small issue, and I'll just go over it once. And yeah, that's all for it. Thank you for watching. If you watched till now, and bye. Good luck, Grand Murder. You can do it.